Hey everybody, in this video we're going to talk about absolute value functions. We'll look at graphs and some of the properties, and we'll talk about equations and inequalities that involve absolute values. So just a reminder, if you've seen this before, even if you haven't, absolute value of a number, let's say absolute value of 2, represents the distance from that number to 0, and so that number is 2 units away from the number 0. If you think of it on a number line, here's the number 0, and 2 is 2 steps or 2 units away. 1, 2. And then also, negative 2 is just the same, 2 units away from 0. So over here, in the negative direction, the absolute value of negative 2 is also positive 2 because it's talking about distance. So the absolute value bars represents the distance from 0 to these values. And so we will deal with functions that involve absolute values. First, consider the case if I have my y value, or f of x, equal to the absolute value of x. So what that would mean is it would actually break apart into two possibilities. If x was already a positive number, then absolute value of x stays the same. So that would be if x was already 0 or more. So if x was greater than or equal to 0. And that's like my example right here with plugging in positive 2, the absolute value is still 2. But if x was negative to start with, then you technically apply a negative to the negative, turning it positive. So let me just show you what I mean by that. So this is if x was negative or less than 0 to start with. So back here, where I had absolute value of negative 2, if I were to take that negative number and apply a negative to it, then I get positive 2. And so that's just what this definition right here is saying. Okay, so that's the possibilities. What we're also interested in, though, is absolute value of our function's y value. Okay, so consider this now. What if I want the absolute value of the output, f of x? It would look the same as f of x if f of x, or the y value, is already positive. So if our output was already positive, it would just stay positive or 0. But if it was negative, then we would apply another negative, turning it positive. So I'm going to explain this by showing you what this would look like visually with a graph. So let's take a look at this example. We're going to graph this parabola, y equals x minus 3 squared minus 4. And so this parabola just looks something like this, where we have our parabola opening upward, roughly like that, okay? Not the best drawing, but something like that. Okay, so that's our parabola. And let's say we were to take the absolute value of this function. So absolute value of y, or absolute value of the f of x, the whole function. So that would mean that anything that's negative or below the x-axis would turn positive. And so the corresponding graph of the absolute value of this function, it would still be the blue parts at the top, so it'd still be any positive values for the parabola, like those two. But then what was already negative has to come up and turn positive. So all of those values, like negative 4, would turn to positive 4, and so on. And so the middle part of the graph would actually end up looking like that. So the absolute value function, there wouldn't be any negative values. Anything that was negative or below the x-axis would turn positive. Now let's talk about some properties of absolute values. And so we're just going to take a look at these 4 properties, and then I'll explain a little bit about them, and then we'll continue on with some examples. So for the first property, number 1 here, it basically says if you want to multiply 2 values, you'll get the same result whether you have the absolute value bars on the outside of each number or on the outside of the product itself. So for example, product of 2 times 3 is positive, same thing as if you were to do them separately, and you would get the same result as if one of these was negative or if both were negative. Okay, so you can test different numbers to see that this will be true every time. Number 2 is very similar, but with division. And then number 3 here, absolute value of a is equal to absolute value of negative a, and this was the very first thing we had looked at absolute value of 2 equals positive 2, and that's the same thing as absolute value of negative 2. So they're both equal to the same number, which is the positive value. So the fourth one, let's just take a look at this. This is called the triangle inequality. It's saying that if I take two separate absolute values and add them, they're either equal to or greater than the sum that I find before I take the absolute value. So let's look at an example of that one. So this would be 2 plus 3, which is 5. And over here, this would be absolute value of 5, which is also 5. So on this one, they were equal. So that's true. So this was definitely greater than or equal to 5. It was actually equal to 5. 5 was equal to itself. Now what if I change one or both numbers to negatives? Okay, so on the left side, it's going to be the same as before. We're going to get 5 because absolute value of 2 and of negative 3 is still going to add up to 5. On the right side, this is now absolute value of 2 minus 3, or negative 1. Okay, so this is now becoming absolute value of negative 1, which is positive 1. And look, it's still true. So 5 is in fact greater than or equal to 1. So either you're going to get an equal value or a greater than value when you separate the absolute values like this and add. Next, let's take a look at graphing some of these absolute value functions. So for example, let's consider y equals the absolute value of 2x plus 1. So we could go ahead and just plug in x values and get out our corresponding y values plotting points. But what I want to do is use the fact that we know about the linear functions, and we can say that we'll consider y equals to 2x plus 1 without absolute value bars. So if this one is a line with a slope of 2, so that's our m, and then this would be our y-intercept of 1, and so we're going to graph this line and then consider putting absolute value bars. Okay, so if we have our y-intercept at 1, 0, 1, our slope is 2, positive 2, so we're going to go up 2 and over 1 and plot points, and we'll do that one again, go up 2 and over 1, and so that would be our linear function over here. If we connect them, then we would get that. Okay, so there was our line. Now, if we're going to take the absolute value of this function, then visually what we would do is anything that was negative or below the x-axis would then move upward and then go above the x-axis. So where we have a point here, then what we would do is we would just take our points, and anything that would be negative is now going to turn positive, and so like this point here would reflect upward, and our graph would now become this one. So the actual resulting graph of this absolute value function is this V shape that I have here in green. So the absolute value graphs, if it's linear, they're going to look like a V shape. So that's one way to do it. Graph it as if it didn't have absolute value bars, and then take anything negative and flip it over the x-axis, turning it positive. Or you can always just plug in some points. We'll just do a couple to verify that it gives us our green graph. So let's say we plug in negative 1, and so we would have negative 1 times 2 plus 1, and then absolute value of that. So that would be absolute value of negative 1 would be positive 1. So at negative 1, we get out positive 1. My tick marks are a little bit off here. So the negative 1 is right here. And if we can verify that that should be negative 1/2, we can plug that in. So absolute value of 0 is 0, and so that is that point right there. So you can always plug in points, but if you recognize that this would just be a linear function, and then you can just take anything that would be negative and flip it over and turn it into positive, then that's one way to graph our absolute value functions. So the last things we're going to talk about are our different cases involving absolute values for equations and inequalities. And case 1 is if there's an equal sign, and cases 2 and 3 are if there's inequalities, and it depends on which way they point for which case we're talking about. So starting with case number 1 here, If you have an absolute value quantity and it equals either a number or even another absolute value, then what you have to do is you have to split it into two. So you split it into two equations because it could have been positive, what the inside of the absolute value equaled, or it could have been negative and then the bars turned it positive. So if you're going to solve these inequalities or equations, we have to consider that. So what you would do, for example, is let's say we had our same line from earlier, our absolute value equation, but this time our 2x plus 1, let's just say that it equals some number. So we'll say 2x plus 1 absolute value is equal to 7. Well, if it's absolute value, what's inside the bars could have been 7, or it could have been negative 7. And if we're going to solve, we have to say, well, which one was it? It could have been either one. So we're going to split this into two. So we're going to split this into two possibilities. So we would take off the bars and start solving. So we would say 2x plus 1 equals positive 7, or 2x plus 1 was equal to negative 7, and the bars were what turned it into positive 7. And then we would just solve each one of these. And so we would get that x is equal to 3, or on this one we would get that x is equal to negative 4. Visually, what that would look like, since we drew this picture earlier, just a few moments ago, we had our absolute value graph. It looked like this, and that was our 2x plus 1 absolute value. And then we were wanting to actually know, when does this equal 7? So if our y value or output is 7, when does this equal it? And visually it would be where these two intersect. So it would be at those two numbers. And if we had this labeled, we would see that this would be negative 4, and over here this would be 3. So this equation has two solutions, and we would list them both as the answer. So similar in case 1, I just want you to be aware that you will also be able to solve absolute value equations that have two absolute value bars in a similar manner. So let's say it was absolute value 2x plus 1, and maybe it was equal to something else like absolute value of 3x minus 2. You still treat it the same way. You would split it into two and take off the bars on the first one and the second one and put a negative. And you would put 2x plus 1 could have been equal to the positive 3x minus 2 quantity, or for the splitting part, or 2x plus 1 could have been equal to negative of that quantity. So we could say negative of that whole quantity. Really similar to what we wrote just below it with the negative 7. So same situation, case 1, it would work if you have two absolute value quantities equal to each other. Okay, so for cases 2 and 3, they're both inequalities involving our absolute values, and it does matter which way the inequality symbol points because we approach it a little bit different. So case 2 says that our absolute value quantity is greater than some value, and so if we take off the bars, we have to split that into two, and I'll show you why it is what it is. So if we are thinking of our number line, and we're saying our absolute value, think of that as distance, is greater than some number k. It's greater than the distance k away from 0. Okay, so it could be greater than k, so further away than k in the positive direction, but it could also be further away from 0 as the number k in the negative direction, so further away, greater than. So the greater than part is important, and it tells us that we should split this absolute value when we take off the bars. So absolute value quantity, when we split that, we're going to say that it's either greater than the positive value, or it's going to be because if you think about going left over here, it's going to be less than the negative value. So one way that I kind of commit that one to memory is when I see an absolute value quantity that says it's greater. So I know that we would say that it's greater than k. I tell myself it's great or than k. And that lets me know to remember I'm going to split this up into this is more than k or less than negative k. And then I would solve it accordingly. And then with the third case, so in that situation, if we had absolute value of some quantity is less than, it's less than k, we're saying essentially that if we're looking at the number line and we're looking at the number k, our absolute value quantity, our distance from k to 0 is less than that number away. So it's smaller than that. So it's less than k away from 0. Less than. It's between 0 and k. But it could also be less than k away as far as distance goes over in the negative direction. So it could be less than this distance in the negative direction. So when we split case 3, when we split up our absolute value quantity in case 3, what you do on this one is you say absolute value of our quantity a plus b, it's still between two values, but it's less than the bigger one, less than the positive k, and greater than the negative k. So we put it in between the two numbers, just like in my picture over here in the green. It's in between the two k values, in between the two numbers. So it's less than the bigger number k and greater than the negative number k. So that's how we would solve case number 3 here. Okay, so let's just take a look at these two examples to practice cases 2 and 3. So our first one over here says 2x plus 1 absolute value is greater than 7. Greater than 7. So this means that the quantity 2x plus 1 is more than 7 away from 0, or in the that would be like in the positive direction, or the quantity is more than 7 away in the negative direction. So that would look like it would be less than negative 7. So these are the two new inequalities that we get from splitting this one. And then you would just solve each one, and we would get that x is greater than 3, or over here we would get x is less than negative 4, and that would be our solution to this one. We would write it usually in interval notation, so we would say that anything from negative infinity until negative 4, and then anything 3 or more, so anything from 3 to infinity. If we plug in any values in these intervals into our inequality, it will be greater than 7. It will satisfy the inequality. And then over here, this one is a less than, so it's saying that our absolute value quantity is less than 7 away from 0. So 2x plus 1 is smaller than 7, or if it's less than 7 away, it's greater than negative 7, because it's in between negative 7 and 0 and positive 7 and 0. And so we set it up as this compound inequality. And then to solve our compound inequality, we would just work on all three sides at the same time. So we would get negative 6 is less than 2x, which is less than 6. I'm sorry, negative 8 is less than 2x, which is less than 6. And then over here, just divide, and we get negative 4 is less than x, and that's less than 3. So that would be the solution to this one. And in interval notation, that would look like between negative 4 and positive 3. Any numbers in between there, getting plugged in for x, would satisfy our inequality. And let's just check one of them. In between negative 4 and 3, this is a interval on the number line, so between negative 4 and 3, pick any number. I'm going to go ahead and just pick a nice number like 0. If I plug in a 0 there, that would be 2 times 0 plus 1. So this would be 1. So absolute value of 1, is that less than 7? And yes, so it does satisfy that inequality. And then the last thing to mention is if there is a different symbol where we have the equal bar, you solve the same way. The only difference is that you use brackets in your solution set. So let's say, I'll just add it in green here. Let's say this was a absolute value is greater than 7 or equal to 7. So if it had the equal to part, then it would change our answer to where we would be able to equal the endpoints. So we would just turn that into brackets. So that would be the only difference there. Okay, so this was our absolute value functions, some things about their graphs and properties. Also, we looked at some equations and how to solve the inequalities. Thanks for watching.